geometric series. So geometric series is when we're going to be adding patterns with geometric sequences. This is going to be our formula that we use, geometric series. R cannot be 1, so my common ratio cannot be 1. Let's get into it, huh? Shall we? So I look at my first question right here. If I'm looking at this, first I'm going to figure out what my R is, so my common ratio. If I look, it looks like I'm multiplying by 2 each time, so my R is equal to 2. My pattern multiplying by 2 each time. I have to figure out what term this is. So right now, 3 is my first term, 6 is my second term, 12 is my third, and so on and so forth. So I'm not sure what term this is, so that I'm going to be using my geometric explicit formula. So my I don't know what term is going to be equal to my first term times my ratio is 2 raised to the n minus 1. So again, you're using your explicit geometric equation. So divide by 3 first, so 1024 is equal to 2n minus 1. This is where you have to use prior knowledge. You have to solve for n. Oh my gosh, 2 is an exponential base. How do you get rid of an exponential base? Do you remember? Do you remember that log base 2 and log base 2 back from chapter 7? So if you put this in your calculator, you would get 10. Exponential base with log base, those cancel each other out, leaving with just x minus 1. So 11 will be equal to n. So 3072 is my 11th term. So first, to figure out my sum, using that formula right at the top of your sheet, it's your first term, so that's 3, multiplied by 1, subtract your ratio, which in this case is 2, the term you're going to, so that's 11, divided by 1 minus r. So if I put that in my calculator, I would get 6,141. That's my first answer. It also says to write this in sum notation. So sum notation, so I'm starting with my first term, so n is equal to 1. I'm going to my 11th term, so that goes on top. And again, you want to use your explicit geometric, so kind of this right here. That's what we're dealing with. Starting number is 3 times my base here is 2, or my common ratio is 2, the n minus 1. And that would be my sum notation with my actual geometric series. Next, if I look at B here, oh, this is nice. It's already in sum notation for us, so that's already done. I have to actually know while looking at this, what does everything represent? So here, if you look at that geometric explicit sequence, this right here is my first term, so that's A1 is equal to 4. This right here is my ratio, my common ratio. Again, this is looking at that formula to match up what's what. I'm going to my nth term. So again, looking at the formula on the top of this page, it's whatever you start with, 1 minus your common ratio, raised to whatever term you're going to. In this case, we're going to 20 because of this right here. And that whole thing divided by 1 minus my common ratio, the 1/2. So if I put that in my calculator, I'll get negative 7.99999, so roughly negative 8. Now you try both C and D. Next, infinite compared to finite sum. So we have this thing, if you add numbers together so much, it will all of a sudden become just one number. What does that actually mean? Well, you're adding such small numbers together that it's not really affecting the actual overall number. In calc, you'll learn about this, and this is what's called reaching the limit. Ooh, you're learning some calc. Go you. So when looking at this first thing is saying we only have finite if for some reason my ratio is going to be less than 1. If my ratio is less than 1. We call that converges. Converges. That means it's actually going to end up being just one number. If for some reason your ratio, again, this is the absolute value, so the positive of that, is greater than 1, that means that we don't know how much it will actually reach. It's going to be reaching infinity if we go to infinity. So we say that diverges. So I'm looking at this, I have to just say if it converges or diverges first, and if it converges, I have to find the sum. So using this equation right here. So first I look at my ratio. What is my ratio? How do I get from 1 to 1/2 to 1/4? Well, my ratio here, it looks like I'm timesing by 1/2. So my ratio is 1/2. So that means this converges. Converges. So I use that formula. So it was my first term. So my first term here is 1. It's 1 over 1, which is in the formula, minus your ratio. So if you do this whole thing in your calculator, you would get -2. So if I were to add up all the numbers from the first term to the 1/1,000,000th term, it will always round to -2. Just like that last problem I did before, how it was -7.9999999999999 and forever, you round that to -8. That means it's going to get super, super close to -2. So we can just round that -2. Second one, I want to see if this is converges or diverges. So first looking for my ratio. So my first thought is, how do I get from 1 to 3? Well, I would multiply by 3. How would I get from 2 to 4? I would multiply by 2. Does that still, yep, multiply by 3, multiplied by 2. So my ratio is 3/2. This is greater than 1. 3/2 is greater than 1. So this diverges. So that's it. I'm done. I want you to do C and D by yourself, and then come to class and show me how smart you are, because you're just so amazing. You, have a great, grand, wonderful time with your life.